Welcome to the Civil Data Analytics video on 3D bridge inspection and evaluation using unmanned aerial vehicles and image reconstruction. In 1967, there was a sudden collapse of the Silver Bridge over the Ohio River at Point Pleasant, with a loss of 46 lives. As a result, in 1968, Federal Act initiated a national bridge inspection program that recognized the need for periodic and consistent bridge inspections. The first national bridge inspection standards were developed in 1971. As a result of this program, National Bridge Inventory database was created. This database has records on over 600,000 bridges in the United States. Traditionally, bridges are inspected by certified bridge inspectors through a combination of visual inspection and taking photographs, handwritten notes, and field measurements. However, this approach is fraught with several issues. First and foremost, it can be very dangerous for the bridge inspectors. Also, the approach can be very time-consuming, which will imply high indirect costs being incurred through the traffic delays, diversions, and so on. To address this problem, Civil Data Analytics Group suggested implementing a cutting-edge technology consisting of utilizing unmanned aerial vehicles for bridge inspections and data collections. This approach includes acquiring high-definition images of bridge components. Once images are collected, 3D models of these bridge components are reconstructed. Our proposed approach implements significant improvements to traditional bridge inspections. It is safer for inspectors, less time-consuming, has lower indirect costs, and it is more objective and accurate in identifying bridge component defects. To prove the concept behind this proposal, the following preliminary steps were carried out. First, we tested the equipment that was supposed to be used in the study, followed by the selection of a representative bridge, and its finally inspection and image reconstruction. The objective of this proof of concept was to show that our methodology works even with the basic instruments. We used commercially available drone with a GoPro Hero 3 camera attached to it. Before collecting the data, we tested the flying capabilities of the drone, and this was the fun part of the project. After assessing the flying capabilities of the drone, we proceeded to selecting a representative bridge. Selecting a bridge is a crucial part of this project. Some bridges may not be suited for drone inspections due to economic reasons, such as bridges with very short spans or low traffic volumes. We used our bridge data visualization tool to select suitable bridge. For people that are interested in this tool, we have a video tutorial for that as well. Check the Civil Data Analytics YouTube channel or our website. After a few checks, we selected Brandywine Creek Bridge in Wilmington, Delaware. After selecting the bridge, we went to the site to collect data. I call this perfect timing because on the same day there were certified bridge inspectors performing the traditional inspection of bridge components, as you can see in the two images on your left side. Once the bridge inspectors left, we proceeded with data collection with our drone, and it's shown on the right side of your screen. We captured images of the bridge components by flying drone around it and taking video of it. Images that were captured by the drone, they were extracted from the video and processed with our custom-made image reconstruction program. The program uses two-dimensional images to create realistic three-dimensional objects. As you can see from the video in the middle, the model captures all the details, including the texture of the selected component. You can assess the level of detail by comparing the model with the images to the right and left of your screen. We compared our 3D model with current state of practice. On the right side is a 3D model of the Benjamin Franklin Bridge in Philadelphia, taken from the Google Earth. As you can see, our model has a higher level of detail compared to currently available 3D bridge models. However, we are not done. In order to improve the quality of 3D model, we decided to use high-definition camera with 50 megapixels image density in order to capture high-resolution images. We selected typical steel bridge element to obtain multiple images and then perform 3D reconstruction on these images. We did not use drone in the test since the camera was too heavy to fly on it. Looking at the video on the right, you can easily see that they were able to obtain a high-quality three-dimensional model. This additional testing proves the concept that mounting a high-definition camera on the drone will result in better 3D models. In the future, we would want to implement this approach into asset management software. Additionally, this tool can be very useful for monitoring bridges in the Rapid Bridge Replacement PT project currently running in Pennsylvania. Thank you.